I should probably rename this slide why we should have started using Robinhood a year ago. But I'm going to tell you a story subtitled yet another reason why my wife hates Lustre. She doesn't really hate Lustre because it pays the bills, but sometimes when it takes a month of my life, she hates Lustre. So I'll kind of go through the overview, what our requirements were, a little bit about Sequoia, how it's laid out on the SAN, some of the available tools, methodology I went through, and then what the next steps were. So, what did I really have to do, right? Sequoia was destined for our secure computing facility. You probably saw the announcement that we achieved that goal. Sequoia is now on the classified side. But we integrated over the past year in our collaboration zone. We had external people from IBM logging in, looking at problems, trying to get it all ready for classified. So we had users doing a lot of scaling studies, science runs, and as of mid-February or so, they had generated about 800 terabytes of block data with about 200 million files. It's really not a lot of data when you're talking about a 55 petabyte file system, but when you have to move all that, it starts to add up. So some silly person decided, hey, it would be easier if we moved all of the data for the users rather than wait for them to try and move it, and then they always scream at the last minute, wait, I've got this important data set. Oh, and it's going to take another week to move it. Right? We had some very rigid deadlines, so we figure, why not? We'll try and move it for them. Bad idea. Did I just talk about all that? Yeah. So we had about 2 to 3 weeks to move the data. We figured at about 20 gigabytes a second, which is the most network we could get at the time, should take about 16 hours. Well, we're not going to get 20 gigabytes a second. Hey, maybe we get 5 gigabytes a second, right? Well, that's still just 4 days, right? Who cares? 2 days, right? So we announced this to users. We told them we're going to move the data for them. And of course, they said, great, and wrote another 400 terabytes of data and another 175 million files. Never tell the users what you're going to do. And of course, we have ZFS compression turned on. So we were seeing about a 1.7 to 1 compression ratio that Chris Marone mentioned the other day. So the real amount of data was about 2 petabytes, so a little more than 16 hours. So this is Sequoia. All those pretty little lines are network cables, lots of InfiniBand. There's about 11 miles worth of cable. So it's not to scale. We do have 48 racks of NetApp equipment for our file system that we've presented in the past. We're hoping for a terabyte a second, but as Chris mentioned, we're getting about 850 gigabytes a second. And that's how it funnels through all those leaf switches into the big core switches. The green is all the OSS nodes in the storage racks. They're all connected into those large switches. So we also have a system called Vulkan, which is a 24-rack BlueGene queue system. This is part of our HPC Innovation Center. It's part of the Livermore Valley Open Campus. It's a collaboration with industrial partners. This system was procured in a partnership with IBM and their deep computing solutions to get industrial collaborators on the system, getting them used to using HP and kind of promote the HPC ecosystem. It's a 5 petaflop system. It's a quarter of the size of Sequoia. About 2 petaflops of that is dedicated to industrial collaboration. The rest of it will be used for our science users on the open side. So that system was brought in. Unfortunately, the file system for that system was brought in after Vulkan was delivered. So they decided to use the Sequoia file system for users to run data on and start generating some science. So we added a couple cables. Really, it's about 36 cables or so, 18 to each switch. And we ran like that for a while until we had the Vulkan file system up and running. So then what we decided to do was move a few cables. So we had about, I think there were 8 QDR links, which was available, that tied this file system in. And the file system is about 100 gigabytes a second, 7 petabytes. And then we tied that into our existing Ethernet infrastructure so we could mount both file systems on our storage interface clusters, our Viz cluster, all of that. So there's about 20 gigabytes per second of bandwidth. I had about 7 clients to move all that data with, and single client performance is not that great. Things were not going very fast. All the utilities that we had were single client, single thread. It was really hard to start moving a lot of data. And of course, where is the data, right? I would run Luster quota reports, see who had the most data, and I'd go and look in their directory, and there was no data there. It's because they were all on a group project, and there were group directories, and their data was spread out across the file system. So it was very difficult to see what got moved and how much of it. So I played around with some of the tools like tar and rsync packs. Tar's xadders preserve Luster striping very well, which is what I wanted to do initially. The rsync xadders didn't seem to work very well with the trusted.star attributes when I was running it as root. So it had some issues. And then both of them complained, gave warnings about directories, but that's fine. But I did recall hearing about some parallel tools from some prior LUG presentations, so I went and looked. And there was mutil, which is a patch set for core util 7.6. Of course, we were running rel 6.2, now we're running rel 6.4. And core utils is 8.4, so I had to go and hunt down the core util 7.6 package somewhere. Applied the patch set, tried to build it, wouldn't build in our environment. So I gave up on that pretty quick because I had a lot of data to move. I looked at DCP, which looked promising. I was able to get it to build, got it running, and then it printed out all these warning messages about, oh yeah, you can't change the ownership, can't change permissions, timestamps, which running as root, I needed to do all those things. So we'll try and fix that later. So when in doubt, grow your own. That's what I did. Fell back to the kind of traditional client-server approach. Basically started up a server that was listening on a socket, and it just basically did a LFS find looking for type D. I just wanted all the directories. And then I could farm that out to a bunch of clients. I could also use a list of directories, so if I did an LFS find ahead of time, I could do that. Or if I was smart enough to use Robinhood, then I would have had all that really fast. So each client connects to the server, asks for a single directory, and then it copies all the contents in that directory from one file system to the other. So this is a simple example of it, right? You do an LFS find, starts giving you a list of directories. All of the clients connect up to the server and say, hey, give me a directory. I've got work to do. So the server farms out, hands them out each a directory. Problem is it's kind of asynchronous, it's all random order, so that causes issues later, which I'll talk about. They disconnect, they operate on that directory, copy all the data over. When they get done, they ask for another directory, and the server gives them one. Ask for another directory, and repeat this for a month, and you copy a lot of data. You kind of need multiple passes. First pass I used tar because I wanted to preserve all that striping. Had some issues with large numbers of files in the directories. For some reason, it would get an error on a single file within that directory. Of course, you could retry, but then you have to copy all that data over again, so that's not very efficient. It does create missing directories in the path as needed, which is very useful when you're doing this asynchronous handing out of directories. But it doesn't remember where it left off. So once you get interrupted, you either copy your data over again, which is not very efficient, or you run something else. So after a few interruptions, right, I started using rsync once I had done a good bulk of the data. It's very metadata intensive. The way rsync works, it was really causing a lot of metadata problems. And it was slow. Originally, I wasn't using the in-place flag, but as I started doing straces on what rsync was really doing and noticing it would open a file to see if it was there, then it would write the file to a temporary spot. Once it copied all the data, it would move that file back into place, and then it would change the ownership and the timestamps and all that. Well, if I'm copying to an empty file system, the existing file is not going to be there. So if you use -- in place, it just copies it straight to where it should be, saves you a few metadata ops. As I mentioned, the xadders didn't seem to preserve the striping and didn't copy directories properly, which seemed to be a regression in 2.3. When I tried the same commands on a 2.1 file system, it seemed to work fine. And rsync didn't really handle the missing directories like tar did, so you really had to run multiple passes on the same directory to get everything copied. Or you could pre-create all your directories, but I didn't do that. So as I mentioned, I only had 70 clients, and I was only seeing about 300 to 500 megabytes a second, which would take more than a month, and I only had a couple weeks. So I kind of borrowed some Sequoia I/O nodes for a bit. There's 768 of those, and there were 192 Vulkan I/O nodes, and I figured, hey, why not? I'll make all of those clients too. That worked pretty well. I was getting up to 5 to 10 gigabytes on average. I think I saw it peak at about 13.5 gigabytes a second. So just throwing more clients at it really helped. Of course, then the science runs users that are trying to generate real data and write their I/O. They kind of were having some issues. So they rebooted all of my I/O nodes, and I had to start over. Eventually, I ran out of block data. I got most of it copied. I was really bound by the number of files. I was really getting about 100 to 200 files a second, and that would take well over a month to get all of it. And that was mostly due to all of the metadata involved, right? Rsync's doing an open, and then it's doing another open, and it's doing a move, and then you got to do the change of ownership and the change of timestamp, and all these things get serialized. And so, every file is like 10 metadata ops, right? So metadata server is going as fast as it can. It's just not enough. So I scaled it back a bit. I talked to the users. I said, do you really need all of these files, or there are some that I can skip, right? And sure enough, some of the friendly users said, oh yeah, I don't need this pattern and this pattern and this pattern. So then I started adding exclude patterns into the tar and the rsync commands to just ignore all that stuff they didn't need. So that was nice because then I didn't have to copy all of it. So I kept trying to get sleep, but I kept dreaming about improvements, right? My wife's like, what are you doing, right? Get some sleep. Stop working. And I had to babysit this stuff over the weekends all the time and make sure the queues were full, because if the queues dried up, then I didn't get any work done, right? So now that's all done, I ran a final scan looking for root-owned files that were left over from interruptions. tar and rsync do all the file permissions and ownership changes last. So if you get interrupted in the middle, you have a whole directory tree structure that is all owned by root, and the users can't get into their files. So I had to do that, found, I don't know, it was about 5,000 files that were in a bad state that I had to clean up, which is not bad when you're talking about 128 million files. I've also been talking with others. Stan Solbeck at NetApp has some summer interns. He said he'd be interested in working on DCP, getting all those functions implemented. Adam Moody at Livermore, who is known for SCR, the Scalable Checkpoint Restart Library, has been interested in making some MPI-ware tools. So we're going to start looking at those kind of things to make this stuff easier. And of course, we need to improve the metadata rates, but everybody knows that. So all in all, of the 1.2 petabytes that was there, I copied about 1 petabyte, which I think is pretty close to all of it, given the exclude patterns that I didn't need. I also didn't copy Chris Marone's IOR data from testing and all of our Lustre developers' other IOR data, because they didn't need it on the open side. And we got about 128 million files, which is not all the files, but there were a lot of users that had 4K files just sitting out there, and I just didn't have the time to slog through all of it. So that's all I've got. The spice must flow. Keep your data moving. All right? So questions, comments, thoughts? And yes, I'll use Robinhood next time.
Just wondering why you didn't call maybe some of the other labs, since we deal with data and we've, I'm sure pretty much every lab has written a lot of tree walk tools and parallel copy tools and
yeah, I didn't think about it. But next time I'll give you a call. Do you have those tools? Are they open source? Are they open source? Are they on the internet? Awesome.